Hello from the other side. Today we are learning about the family of logarithmic functions. Basically, we just cover graphing logarithms. I'm going to do walk you through an example and then kind of have you try one out on your own. So we're going to start off with the function log base 3 of x, and we're going to make it simple. Okay. So let's just remind ourselves what a logarithmic function, right? It's an inverse of an exponential function. It's the inverse of 3 to the x. So normally in a 3 to the x function, right, your x values are just like normal numbers, and then your y values are your powers of 3. So like now our x values are powers of 3, and our y values are kind of like the numbers on a number line. So what you want to do basically to come up with a table is you want to figure out what your powers of 3 are, and then fill in those for your x values. Like for example, 3 squared, so that's a power of 3, right? That's 9. So take that in your table, right? 3 cubed is 27. You put that on your table. And 3 to the 4th is 81. So you put that in your table. And then, of course, 3 to the 1 is 3. Right? 3 to the 0th is 1. And then the before 1, right, are fractions, and basically they're 1 over the previous powers. On the right side of 1, right, is the number 3. So on the left side will be 1 over 3. And 2 spaces over from 1 is 9. So then 2 spaces over from 1 on the left side will be 1 over 9, right? So then you just fill in with those powers. So there you go. So those are the exponents. For example, if we start on the right side, 3 to the 4th is 81, so then you have the point 81,4. 3 to the 3rd is 27, so then you have the point 27,3. 3 squared is 9, so you have the point 9,2. And 3 to the 1st is 3, so you have the point 3,1. 3 to the 0th is 1, so you have the point 1,0. And remember, the negative exponents is just the reciprocal of the power. So 3 to the negative 1 is the same as 1 over 3 to the 1. So it's 1/3. And 3 to the negative 2 is the same thing as 1 over 3 squared, which is 1/9. So you have 1/9 negative 2 and 1/3 negative 1. Okay, and then after you make your table, you just plot those points, right? So those are all our points, right? It's not very obvious because the graph goes all the way to 81, but yeah, 1/9 negative 2, 1/3 negative 1, 1, 0, 3, 1, 9, 2, 27, 3, 81, 4. And then you just draw the curve. And it's important to remember that the y-axis is an asymptote. Remember, it's important to remember that the domain is greater than 0, not equal to 0. And the range is all real numbers, right? It's the opposite of exponential functions. Okay, let's look at a different function. Log base 6 of x. Okay, so now that you know the pattern, the point 1, 0 will be on every graph, right? Because beside any base, right, to the 0th power will always be 1. And then what I like to do is just fill in the right side of 1 with powers of the base, and then the left side with the reciprocal of the powers. So for example, these are the powers of the base, right? 6 to the 1 is 6, 6 squared is 36, 6 cubes 216, and 6 to the 4th is 1296. And then the left side of 1 are the reciprocals of the powers. So 1 6 is 6 to the negative 1, and 136 is 6 to the negative 2. And then remember, your y values are just what the power would be, right, of the base. Sorry, I yawned. Hope you're not tired. I hope I'm not boring you. Okay. And then the same process. Just plot the points on your graph and then connect the curve. Remember, your y-axis is your vertical asymptote. Jeez. Okay. So topics: graphing, logarithms. Basically, the steps are: you first make a table, and then you want to start with the point 1, 0 somewhat in the middle of the table, right? And then you fill in the right x values with increasing powers of your base, right? So that's why like the right side of 1 was like 3, 9, 27, 81, or 6, 36, 216, 1296, right? And then you fill in the left x values with decreasing powers of base. Remember, they will all be in the form 1 over n, where n is powers to the right, or to the left of 1. And to graph, you just plot the points in the table and make sure you draw the asymptote. So that's our short lesson for today. Hope you enjoyed it. See you later.